Hello, math lovers. Today we're going to talk about section P2, which is part of the prerequisite chapter. This is, again, a review chapter for you on exponents and radicals. We're going to start in our textbook on page 15, looking at the properties of exponents. There is a beautiful chart right here in your book. All right, so take a look at that. Open up your book along with me. And right here we've got all the properties, and there's an example of each one. You need to have some discipline in this chapter, okay, in this section. I do not want you pulling out your calculator. I do not want you putting out your calculator and putting the problems in. Like, for example, if you had 3 squared times 3 to the 4th, I do not want you putting that into your calculator. I want you to see 3 to the 6th, and I want you to know that 3 to the 6th, come on, you guys are fast with your numbers. You got good number sense. You wouldn't be in honors otherwise. I want you to know that 3 to the 6th is 729. All right, so fight the urge to use your calculator on these. There are 2 properties which I think are pretty new to you. Maybe the negative exponent and the fractional root. So I'll spend a little time on those. But otherwise, I think these are all reviews. Look at them in your textbook and spend some time with those. Okay, so looking at the chart of properties of exponents, there are 2 that might be new to you, and that is the negative exponent. So if you have x to the negative second, what that's saying to you is, hey, I've got a base of x, and that negative means to drop it down to the denominator of the fraction. And once that exponent has gotten what it's wanted, the negative disappears. All right. So similarly, if I change that and I make that say 5x to the negative second, you know, that 5 doesn't have a negative on it. That 5 stays in the numerator. But that x to the negative second, that drops down to the denominator there, okay? So be mindful of that. Similarly, if you say you're working with a fraction, say we have 3 over x to the negative second, all right? That negative exponent is telling me to take this base and move it up to the numerator of the fraction, which would be 3x squared, all right? So that's one thing might be a little bit different from previous years. And the other thing is your fractional exponent. So if I have a to the 2/3, all right? So this is what is power. I write this as power over root. All right, so it's power over root. So your base here is a, and that's what's going to go inside the radical sign. The radical sign there would have an a in it. And the power on the term is that 2. So the 2 is going to go with the a. And the 3 is my root. So that's how many I need. So usually what we do is we work with square roots. And again, mathematicians, I say it all the time, mathematicians, we're inherently lazy. We like shortcuts. We like shorthand notation. We don't always write the root of 2 in there when we have a square root. But think of where the word square comes from. Square has 2 sides. So our root is a square of 2, has 2. So if I say, hey, what's the square root of 16? I'm really saying to someone, hey, I've got an index there of 2 and I've got 16. How many do I need to get 2 factors exactly the same? And that's obviously going to be 4. Okay. All right. So branching out a little bit. So let's talk about scientific notation. I know you covered scientific notation in your science classes. I like to think about scientific notation as like a fill in the blank. All right. Every scientific notation, it's gonna look like this. All right. So right here in this first box, you are gonna have a digit between 1 all the way to 9, right? And then you're gonna have your decimals. You cannot have more in correct scientific notation than 1 digit. And then times 10 to the whatever power. If this is a negative, the numbers are going to be very, very small. You move your decimal point to the right. If this is positive, the numbers are going to be very large. You move your decimal points to, I just said that backwards. Let me say that again. If this is negative, you're going to move your decimal point to the left. And if this is positive, you're going to move your decimal point to the right, and the numbers are going to be very large. Okay, so again, scientific notation, I think you're pretty familiar with. Properties of exponents, I think you're pretty familiar with. Okay, what I do want to talk about are roots, all right, or radicals. So radicals, they're pretty radical, man. Okay, radicals, all right. So you've got different parts of your radical. This n here, this is what's called your index. And this is what I was just talking about. It tells you how many you have to have. This symbol here that I made a little too big is called your radical. All right. And the number that's underneath here is called your radicand. Mathematicians, we all need to be using the same language. As I just said, a square root, I can have a square root. I could say the square root of, 12. right? And right away, you're going to say to me, hey, Ms. Glennon, that's 2 root 3. I know that, right, off the top of my head. It's implied that there's the 2 there. Nobody writes that, but, you know, purposely we would. Just you know, I know you've done a ton with square roots. What I do want to refresh your memories about square roots are that we cannot leave a radical in the denominator. That is not rational. The denominator must be rational. So for example, and this is going to call back to your geometry days, 1 over root 2, right? You cannot leave that. The reason is, if you think about the definition of a fraction, and your elementary school teacher probably explained it with a pizza. You know, my denominator is how many pieces I'm going to cut that pizza into, and the numerator is how many you get. So if you had 1/3, I'm going to take a pizza, cut it into 3 parts, you get 1 of them. How in the world are you going to cut a pizza into root 2 pieces? It doesn't make any sense. Okay, so it goes back to the basic definition of a fraction. All right, so what you did in your geometry classes last year is you rationalized, right? You rationalized like crazy. I'm assuming that you remember how to do all of that. What might be new for you is you're going to see problems with me like 2 over 4 minus root 7. Okay, so you're going to need to rationalize this. Now, if I go ahead and multiply this by itself, right? If I go ahead and I multiply numerator and denominator by 4 minus root 7 over 4 minus root 7, here's a problem. I'm going to have a middle term, and I want that middle term to fall out. So what I need to do is I need to multiply by the conjugate. The conjugate, remember, is the opposite sign. So I'm going to go ahead and I'm going to FOIL my numerator, distribute that 2. So that would be 8 minus 2 root 7. Okay, no big deal. Just make sure you distribute. And then here are your denominators. If you want to go through, you don't trust me, you know, 4 times 4 is 16. 4 times root 7 is 4 root 7. Multiply these two, negative 4 root 7. Middle terms are going to fall out. And then you've got root 7 times root 7, which is 7. So it would be minus 7. And of course, our answer here is going to be 8 minus 2 root 7 over 16 minus 7, which is 9. Now, at this point, if you could reduce that, you would go ahead and you would reduce it. But I do not think we can reduce that one today. All right. I want you to think about problems that such as, if I said to you, hey, kids, what is the square root of 4, right? You're going to say to me right away, 2, right away, because you're thinking about the principal root, right? This is the principal root. But what's different if I say to you, hey, go ahead and I want you to solve x squared is equal to 4. Now, you've got to come up with all possible solutions. Here, you just wanted the principal root. Here, you've got to come up with all your possibilities. So in this case, you would say x is equal to plus or minus 2. All right. So here in this class, if we just have a square root, we're assuming we're talking about the principal root. But if we are solving, we want all possibilities. All right. Before you start your problem set today, I want you to check out, there's a nice chart on page 20 on all the properties of radicals. Right. Property of radicals. Have fun.